as you remember, in the last few sessions, we were talking about the examples for the concept that we been through after midterm and get prepared for the final exam. Now we are at homework 5, question 4, and we are moving forward to finish that. Hopefully, I'm looking forward to finish that this session. So we know that we are already covered everything for the final exam. Any question generally about the previous sessions or the concepts? No? Okay, so let's continue for question number 4 of homework 5. In question number 4, we had, again, joint random variables x and y. And the question already gave us the PMF for that joint random variable. Now, if you look at the PMF, you would easily find that low x is getting numbers independently. The y random variable is conditioned, and it's kind of like the condition and the span of the y is depending on the value of x. So the higher limit that y could get in our PMF is y equal to x. Now, the question asks us to find the marginal PMFs for random variable x and for random variable y. And then we would calculate the expected value for each of those random variables, expected value for x and expected value for y. Again, as we talked about it during the course and in our previous session, when we wanted to calculate a marginal PMF for a random variable using a joint PMF, okay, what we are gonna do is we have to integrate all the probabilities over all the other random variables that we have. So now we have x and y. If we want to calculate the marginal PMF for x, we have to integrate the probabilities over the y. Now, let's do that. That means we have a summation over all the values of y. What are the values that y could get is from 1 to x. And because the probability distribution is even, so for each point, we have 1/50 chance for the probability. What that means is that if we add up x values, each equal to 1/15, basically the result is going to be x over 50. Is that clear? So we are going to add from 1 the values, the lower limit of y is 1, the upper limit is x. From y to x, all the probabilities regarding the random variable y. And we have our marginal PMF for x. Same goes for the calculation of the marginal PMF for y. We have to calculate integrate over the other random variable, in this case over the x. But remember, although we know that originally x getting the values independently, but we still have the condition that relates y and x together. Is that clear? So this is our condition. We already gone through that during the course, the session within the course, that we are calculating the marginal PMF of y and we integrating over x, but because still y is participating on the discussion, on the analysis, okay, we have to consider the condition between y and x, okay? So when we wanted to calculate the summation for x, it's gonna be, we have to consider the lower limit because y is gonna go from 1 to x. So the higher value of y is going to be x. That means the lower value of all the x's involved is going to be y. You know the reverse of that condition. So when you want to like integrate, same way that we here count from 1 to x, for the y, we have to count from x to whatever upper limit x is at. Are we good? So that way, we could calculate the PMF, the marginal PMF for y. So again, remember, if you have a conditional range for any of your random variable, okay, always, always, always in whatever situation, in whatever marginal PMF you want to calculate, or CDF, or whatever analysis that you want to have, always you have to include that condition, okay, because it would affect your upper limit and lower limit of the data. If you have problem to recognizing that, I encourage you to actually draw the graph of the point that you have in your span or in your range of the two random variables. Okay, so draw the x-axis and y-axis, put out all the numbers, all the points, the coordinate of x and y, and implement the condition. That way, it would avoid you to make any mistakes over this kind of like situation, in this kind of situation. Now, any questions so far for marginal PMF? No? Now that we have marginal PMF, the question also asks us to calculate the expected value of x and expected value of y. How to do that? Easy. We have the formula. Expected value is the summation in this random variable and integral in continuous random variable of x, probability of x. Okay, so we have a certain number of values for x. X here changes from 1 to 5. Okay. Now that we have the marginal PMF of x, we know the values of x, so we add the multiplication of x PMF of x, and then we have our calculated expected value for x. Same goes for y. We have the PMF of y, marginal PMF for y. We know all the y's, okay? So we could calculate the summation of those multiplication, meaning we could calculate the expected value of y. Is that clear? Any question about this problem, problem 4? No? Good. Let's move on to the problem 5. In problem 5, again, we have x and y as joint random variable. The problem already gave us the PDF of the joint random variables, the PDF that describe the probability distribution for all the coordinate x and y. Okay, and we also have our boundaries for x and y and the conditions that limit the range when we want to like move around in our span. The question first asks us what is the value of the constant C that we included in the PDF. Now, normally you already, I think, you know how to attack this kind of problem. We use the axiom that we had as a ground rule that, okay, the summation of all the probabilities all together should be equal to 1. That means if you integrate, double integrate, we have two random variables, x and y. If you integrate over x and y for all the possible outcomes, all the possible elements within our problem, the value of the result should be equal to 1. If you do that, if you do the integral over x and y, like for example here, first we do integral over y, but we know that the y is limited by our condition. So the y is always lower or equal than 1 minus x, okay? So the upper limit of y is 1 minus x. and the lower limit is y should be always positive, so it's 0. Sorry, non-negative, so it's 0. Okay, so we do the integral over y based on our condition, and then we do the integral over our x. We have the value because it should be equal to 1. That means here we could calculate the value of c. Any question about that one? No? Okay. The next part asks us for what is the probability of event that y is higher or equal than x. Okay, now, when we say event that y is equal or higher than x, as before, when we wanted to calculate the probability, okay, of a certain interval, we have to calculate or add all the probabilities within that range. Okay, so for x and y, we know that our y is limited here by the event to values higher than x, okay, or equal than x. This is the event that we are looking. So because of the event, we know that the lower limit of the range of y is x. Also, because of the condition that we had in our PDF, we know that the upper limit for y is 1 minus x. So it cannot exceed that value. Now that we know the higher limit and upper limit for y, we could integrate over the y. Okay. And after that, we could integrate over the values of x, knowing the upper limit and lower limit based on our condition. The lower limit is going to be the 0 based on the PDF as described range. Okay. Now, the higher limit is 1 over 2 y because of, is that true? Or I'm making a mistake? This is x is going to be from 0 to, okay, 1 over 2. Yes, because of the two conditions that we have. One is the x should be less than y. The other one is the x, again, here. Where are that? X should be less than 1 minus y. Okay, so we have those conditions. We have lower limit and upper limit. We integrate over that, and we have our values. Again, if you draw the span, it's easy to recognize and kind of visualize what it means. The intersection of our condition for PDF and our condition for events that we have makes the x to be limited to a certain value. Okay, so this is the higher limit of x, and this is the lower limit of x based on the visualization. The next part wants us to calculate the probability of another event when x plus y is less than 1 over 2. Okay, again, we could do the visualization. Okay, this is the range of our x and y based on PDF's range for x and y and the condition that we had. And this one is the margin for the condition that events apply to our problem. Okay, so we had x plus y equal to 1 as the condition that we had here. Okay, that limited our range and limited the values that x and y could get. And now we wanted to like, on top of that, we wanted to calculate the values of interval for x and y's when x plus y is always less than 1/2. So it covers only this part of our sample space. Is that clear? So to do so, again, we are going to do the integral over x and y to calculate the probability of the event. But now you have to pay attention. Now, when you want to like integrate over y, now it's the condition in the PDF range is not the one that limits the values of y, because we have much harsher or like much stricter condition in our event. So you have to calculate based on like kind of like the intersection of the two conditions. Okay, so whatever is the more stricter, it would affect the upper limit and higher limit of your integral. Based on that, you do the integrals for over the y and x, and you have the value for the probability of that event. Any question regarding what we discussed of how to calculate the probability of an event based on the PDF? Are we good? Okay. Let's go to the problem number 6. In this problem, we also have a two random variable x and y. The PDF is given for those random variables, the joint PDF actually. The question asks us for the probability of two events. One is x higher than y, the other one is x plus y is less or equal than 1. We know to calculate the probability of interval, we have to do that double integral. But because of the event, so far the PDF would not limit our range. Okay, so the only thing that limits our range is the condition of the event. Okay, so we have to consider the condition of event. We know that the y is limited by x. So you could kind of draw that to visualize that. So the y is going to be integrated from the lower limit, which is 0, based on the PDF, and the upper limit, which is x, based on the interval that we discussed, the event that we wanted to like calculate. And x is limited from 0 to infinity, because y is not limiting the upper limit of x. So doing the two integral, we could calculate the values of this probability. I really encourage you. Yeah. Okay. Or you have a condition for your event. I really encourage you to draw the sample space. Okay, draw the range. So that way you could see, okay, what is the lower limit, what is the higher limit for both x and y. And you would not get kind of like confused of, okay, when should I apply that condition, or when should not I apply it? I'm not supposed to apply that condition. Same concept goes for the next event, x plus y less than 1. Okay, we have the margin for y. Based on that margin, if x plus y is less or equal than 1, and y is limited to 1 minus x, basically you could see that x is gonna be limited to 1. You know, combine those conditions, do the mathematics for that, you would see that the upper limit, because of that condition, the upper limit for x is gonna be 1. Also, you could draw that based on my suggestion, find what is the values that x and y is getting over the within that sample space. When you had the lower limit and upper limit, the rest is just doing an integral, which you already know how to do that. Any question? No? The next one asks for minimum of the event now says that the minimum of x and y is higher than 1. A little bit more challenging. Now, the event when the event says the minimum of x and y is more than 1, that means both of them are higher than 1. Is that clear? When it says minimum of x and y should be bigger or equal than 1, basically that means both of them are higher, because if x the minimum, definitely y is bigger than x, so it is going to be higher than 1. Okay? So we could translate this criteria to the new interval, and now we have our interval, meaning y is changing from 1 to infinity, x also changing from 1 to infinity, so we have the lower limit and upper limit of our interval, x and y. We know how to calculate the probability of interval. We do the double integral considering those limits. Next part asks for maximum of x and y less or equal than 1. Again, same kind of like ideology, same kind of like logic. If the maximum is less than or equal to 1, that means both of them are less than or equal to 1. Okay, so you have the interval, you know the range of x and y, you know the condition. We do the double integral and calculate the values for the probability of that interval. Is that clear how we solve that? Any question regarding that question, that problem? No? Okay. Question 7 also is a same question. Different type of PDF. Why different? Because we have the values, the range for x and y, but one of the random variables is conditioned based on the other. The range of one random variable is conditioned based on the other. The question asks us for marginal PDF for x and y. To do so, we know that for marginal PDF of x, we have to integrate over y. Now, again, I encourage you to draw the range so we avoid confusion. Okay? We know that the y is changing from 0. 0 is the lower limit. Okay? And the upper limit based on the PDF is x squared. Okay? So when you wanted to do the integral over y, your y is changing from 0 to x squared. That way, you could have your marginal PMF over x. For marginal PMF over y, we integrate over x. Okay? But again, we know that the minimum value for x and maximum value for x is 1 and minus 1. But also we know that the values of x also limited. Okay, the points that these x could get also limited with the condition that we have in our PDF. So for the half of PDF, you could see that x could get anything, any value between -1 to minus y, and for the other half, it could get a square root of y to +1. Is that clear how we get to this conclusion? Overall, generally, it changes from -1 to 1. But PDF, the condition that we have would limit, again, x, okay, to a square root of y. because y should be lower than x squared, meaning x should be higher than the square root of y, the amplitude of x, okay? Meaning either x is less than minus square root of y or more than the square root of y. Is that clear? So what the condition of the PDF says that the x is bigger than the square root of y or less than minus the square root of y. And another condition says that the x is between -1 and 1. So if you do the intersection between these two conditions, you would see that the x only gets the values between -1 and minus the square root of y, and the square root of y and 1. So these values are not available for x because of the condition that we have. Is that clear? So now we have our integral because we have two separate intervals. We have two integral basically. We do the integral over x and we have our marginal PDF for y. Is that clear? Any question regarding that? No? Okay. So let's move to the question 8. Again, in question 8, we have a joint random variable PDF. The range of x and y already defined. And we know that the constant k, an unknown number, is going to be, based on the question description, a positive constant. Okay? Now, first, the question asks us for k. Again, using the axiom. The integral over all the possible probabilities should be add up to 1. Okay, so if you do the double integral over the range of y and x, okay, the result should be equal to 1. So if you do the integral, you will find that the k plus 1 over 4 is the result of that double integral over the range. Because it should be equal to 1, that means you could calculate the value for k. Are we good? Now, the second part asks for the marginal PDF, the second and third one, the marginal PDF for x and y. Let's go that similar because they are all same concept. For marginal PDF of x, we integrate over y. For marginal PDF of y, we integrate over x. There is no condition to restrict our range for x and y, so it's very easy, kind of like question. We just have to integrate over the range of y to calculate the f of x, and integrate over the range of x to calculate for f of y. Are we good? Easy? Okay. Now, the last part asks us if x and y are independent. Okay, what was the condition of independency for two random variables? Anyone can remind me of that? What was the condition that we used to prove or disprove the independency of two joint random variables? How we would check the independency of two joint random variables? We have the marginal PMF, okay, and we have the joint PMF. If x and y are independent, the joint PMF should be equal to the multiplication of the marginal PMF. Remember? Now, so we have the f of x and y. The question already gave us. We already calculated the f of x and f of y, the two marginal PDF. Now, if the multiplication of the two marginal PMF is equal to that joint PMF, that means they are independent. If not, they are not. If you do that, you would find out that, okay, it's obvious that, okay, we have this equality. If you do the multiplication, we see that we have the equality. Thus, X and Y are independent. Is that clear? Problem number 9 also had the same kind of like approach. We wanted to like have the, oh, it's different, but yeah, sorry. We had the PDF of X and Y, the joint PDF of X and Y. Now it asks you to calculate the other information about the X and Y. So we want to like calculate the expected value of X, variance of X, expected value of Y, and variance of Y. I'm grouping these parts together because they are similar. Now, we know the expected value of X is X f of X. Now, what is f of X? Is the integral of our joint random variable over Y. So what we have to do, so this part is going to be this X aside here. This part is actually f of X. How we calculate f of X. You could do that individually, like first calculate the PMF for X and Y, or like this solution, you could merge these steps together. Okay? We have the f of X if you do the integral over Y, and then X f of X is going to be the formula for calculating the expected value of X. Is that clear? Any question of what we done? And any confusion about the solution that I put on a screen because I merged the two steps. I didn't individually calculate the f of X. I merged it into the formula for expected value. Is that clear for everyone? Same process goes for expected value of Y. We could integrate over X and find the f of Y, and then calculate the Y f of Y. Or, like I show here, we could merge these two steps and integrate values of Y times that integral. So, see, pay attention in these two. See here, let me go back. The joint random variable, the joint PDF is 4xy. What I have here is 4x squared y. So I multiplied that x because expected value is x f of x. Okay, so this x added to that. Here also in a y, you could see that the y is squared. So this is actually y f of y. So this is what I want to point out. Same process, you could calculate the second moment, expected value of x squared and expected value of y squared. Okay, it's going to be the same process. And when you had these two values based on the formula for variance, you know that the variance is going to be the second moment minus expected value squared. So based on this formula and this formula, you could calculate the variance of x and y based on your joint random variable PDF. Any question about these two parts? How we approach that question? Pretty much, it is very straightforward. You just have to follow the formulas. Okay? The part C asks for covariance of x and y. What was the covariance of x and y? The covariance of x and y, based on the formula that we had in class, is expected value of xy minus the multiplication of the expected value for x and expected value for y. We had that formula in our session. So in order to calculate the value of the covariance, you already had these two values from the previous step. Okay, you only had to calculate the value for expected value of xy. You would deal with that xy as a function. We already know what is the expected value of a function g, which is g of x and y, which is the double integral of g of x and y, f of x and y. Remember? So this x multiplication is actually a function. So you put that in here. You know f of x and y is 4xy. The function is x times y. So you could see they are multiplied into that formula. Do the integral and you have your expected value of xy. Is that clear? How we deal with that? Are we good? Okay, now that you have the expected value of xy and you already calculated the expected value of y and expected value of x in the previous part, you could calculate the value of covariance, which coincidentally here we have equal to 0. Now, what is the expected value? The two last part is what is the expected value and variance for x plus y? Again, we deal with that like a function. There is another g. I did it too much, right? Yeah. There is another g. So expected value of x plus y, you could calculate that directly from the formula. So it's going to be x plus y times f of x and y double integral. Okay. Or you could use the linear property of the expected value, which says expected value of x plus y is the summation of the two expected value. Is that clear? So this is easier way. If you have the notes from the sessions, you could easily calculate that. If you didn't find that, it's just doing a double integral. You deal with that like this function, and this function is x plus y. So if you want to do this integral from direct way, it's going to be double integral of x plus y times 4xy dy dx over the upper limit and lower limit. And you should get same result. Is that clear? Now, for variance, we know the variance of x plus y is going to be equal to the variance of x, variance of y, plus two covariance of x and y. You already have the values. You could calculate that. Now, if you don't want to use this formula, again, you could use the formula for the variance, the direct formula for the variance, and calculate what is going to be the x plus y variance. Are we good? Any question regarding that problem? No? Good. Now, I think it's the last problem, random variable. Problem 10, again, we have two random variable x and y as joint random variable. We have the probability. Pay attention that we have a conditional range for x and y. They're depending on each other. And the question asks us to find R of x and y and the expected value of e to the power of x plus y. Now, R of x and y is basically the, when we say R of x and y is the same as E of x and y. Okay, EXY. This is in the covariance formula. When we had the covariance of x and y is equal to E of xy plus, no, sorry, minus e of x, e of y. This term here is r of x and y. This is another terminology to use that, to show that. Okay, so I believe I already have that in the PowerPoint, so you shouldn't be having a problem to like know that, but I wanted to like mention it again. Now, you have to do the expected value for that, meaning you have to do the integral, double integral over the range of x and y. Okay. We know the conditional situation that we have for the upper limit and lower limit. I really encourage you to calculate, to draw the values for lower limit and upper limit, so you know you don't get confused over the upper limit and lower limit of the integral. And based on that, basically r of x and y is the expected value of xy times the f of xy. You do double integral over the upper limit and lower limit based on the range. And you have the value. For e times ex plus y, again, we deal with that part as a g, as a function. We are calculating expected value for the function g of x and y, knowing the PDF of x and y. So it's going to be the double integral of g of x and y, f of x and y, dy dx over the upper limit and lower limit based on the condition. This g is e to the power of x plus y, which basically means the multiplication of the e to the power of x, e to the power of y. Okay, do the double integral. You have the values for f of x, do the double integral, and you have your final answer for expected value of e to the power of x plus y. Is that clear? Are we good? So this is the last question. I wanted to like make sure that everyone is clear for the concept of how to calculate the marginal mean in PMF. When you have two random variable, you have to be able to calculate the expected value of each of the random variable, and you have to calculate the covariance and the expected value for whatever function described by x and y. Okay, so is there any problem on that? Any question about that? No? Are we good? Perfect. Now, let me first stop the recording.